All right, we got SAT 22 for week 24, another student-produced response question. Let's take a look at it. The function f is defined by f of x is equal to negative a to the x plus b, where a and b are constants. In the xy plane, the graph of y is equal to f of x minus 15, has a y-intercept at, what? 0, comma, negative 99 over 7. Okay, the product of a and b is 65 over 7. What is the value of a? Let's take a look at how we did on this question. Well, we can see that we have a variety of answers here, ranging from negative 65 to positive 65, with one little spike here at, well, it's hard to see, but it is specifically at 5, which was the correct answer. And 77 of us, 65%, said that was the correct answer. Okay, and we rated this thing. It was definitely on the medium to hard side of the SAT kind of questions. So let's dive into the actual solution here. And of course, the major question that we sometimes ask is, can you do this thing on Desmos? And I think you can, but you got to be clever about it. So let's start with the equation that they gave us. F of x is equal to negative a to the x plus b. So given that the actual variable here is in the exponent, this is, of course, an example of an exponential equation or an exponential function. Exponential function. So that's usually associated with exponential growth and decay. It's also associated with stuff like finances, compound interest, and stuff of that nature. And this is probably the first opportunity that you had to be introduced to something called an asymptote. So an exponential function usually looks like this, would be an example of exponential growth, and you have yourself a horizontal asymptote here at the x-axis, which just means that our graph is going to get closer and closer and closer to that, but never touch it. Okay, the plus b does shift this thing up. However, the negative that's right here actually reflects this thing across the x-axis. Okay, so this is what our graph actually is going to look like. All right, and let's go ahead and take a look at this on Desmos. So I'll type it in just like we saw it, and then use Desmos to add in some sliders here. So f of x is equal to negative a to the x, and that negative sign is actually not associated with the a. You compute a to the x, and then you negate it. The reason why is because raising negative, like in parentheses, the quantity, negative a to the x doesn't always work out to be a real number. Anyway, that's some algebra 2 stuff for you. And then plus a b, 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 b. There it is. And then we'll add sliders to all of these things. So right now it just looks like a horizontal line just because of the values of a and b. So I will shift these things around and you can see what this graph looks like. So roughly the kind of thing that I was just showing you. All right, and then that's not even the equation we're dealing with. We're actually dealing with y is equal to f of x minus 15. So the minus 15 here, as a transformation on our graph, is going to take this function and then shift it down 15 units. So it's basically going to take this guy and go down 15 units, right? And I'll do that on Desmos as well. Desmos. So we'll go to y is equal to f of x, and then we'll just subtract 15 from it, so minus 15, good to go. And then actually hide this graph because we don't care about it. We care about this other graph, and you can see that just move this thing down 15. All right, so here, like if at this level, just playing around with the sliders here, trying to get stuff to work out, well, there's nothing for us to match up with just yet. Maybe we can pull something from the question and bring it in over here and see if we can solve the question that way. So it gives us a couple of things, like for example, it gives us this y-intercept. Y-intercept happens whenever you plug a 0 in for x, and then the y should be equal to negative 99 over 7. What a strange value. So here, I'll just write this thing down. So this thing goes through 0, comma, negative 99 over 7. So you could, if you wanted to, you can come down here to another box and then type this in as an ordered pair. and then negative 99 divided by 7, and maybe even label that thing. And you can maybe shift this thing around and then try to get that thing to match up. The problem is that there's actually an infinite number of combinations of A and B at this point that you can make happen to go through that point. So they do give us another parameter here, and that other parameter is that the product of A and B, so I'll write this maybe over here, so A times B is equal to 65 over 7. So again, that's something that you could perhaps put into Desmos as, and we want a number to shoot for, which is a 65 divided by 7. So we have this number that we're going to try to match up. And then you would have the product of A times B. So A times B. And then you can see right down here, we got a 2.4 currently, and you would just try to make those two numbers match up. But you can see like how crazy this would be to get all of these things to match up. Not only does the function have to go through that point there, but then also the A times B has to be about 9.28, blah, 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 right? Oh, but there is a way to simplify it, but we'll get to that towards the end of this solution video, because really, I think it's quicker and easier to solve this thing algebraically. What I mean by that, of course, is I would just take the 0 here and plug it in for x, and then take the negative 99 over 7 and plug it in for y. While I'm doing that, I might as well go ahead and plug in f of x, where this function actually f of x is in the y equation. So y is equal to a negative a to the x plus b, and then minus 15. So I just substituted in f of x right in there. And then let's go ahead and plug in our point that we were given. So negative 99 over 7 is equal to negative a to the x plus b. Whoops, no, the x is 0, and then minus 15. So this is really convenient, because anything raised to the 0 power except 0 is equal to 1. So a to the 0 equals 1. But I do have a negative sign out front of it, which is going to make that negative 1, of course. So simplifying here, I get a negative 99 over 7 is equal to negative 1 plus b. Combine our like terms here. Whoops, don't forget negative 15. Okay, so combining our like terms right there, that'll make a negative 16. And like I said, this is really convenient because it gives us a way to just solve for what the b is equal to. So negative 99 over 7 is equal to b minus 16. And then all I have to do is add the 16 over. So b is equal to whatever 16 minus 99 over 7 is. So you can absolutely do this without a calculator, but my gosh, save yourself some time. Just throw that into the calculator. Let's compute whatever 16 minus 99 over 7 is. 16 minus 99 divided by 7. And go ahead and turn that thing in the fraction. Right underneath the 8, there's a little fraction conversion button there. So it's 13, a nice neat 13 over 7. So 13 over 7. So this is going to be important, because now we're so close to the actual solution, because it gave us, remember, this little equation, or this relationship between A and B, supposed to be the product is equal to 65 divided by 7. Oh, and this thing has a divided by 7 in it too. Okay, for our B. So my A times B, don't know what the A is, but the B is 13 over 7 is equal to 65 over 7. And remember what this question's actually asking us, which I never even mentioned, is what is A? So we're solving for what the A value is. So if I was going to solve this thing by hand, I would multiply both sides by 7 so I can get rid of all of these denominators here. And then we get a way, way simpler equation of 13A is equal to 65. Divide by the 13, and A is equal to 5. And there's your answer. And of course, we would just type that sucker in. There's no multiple choice to match this thing up with. Okay, so let me show you how we could get that, maybe with less grief and less, I guess, luck, by moving these sliders around. But what we're going to do is turn the two sliders into a single slider. And we're going to do that by looking at the fact that we're looking for the value of A. And if I solve, excuse me, oh my gosh, if I solve this equation for B, I will have something to substitute into this f of x function. And then I'll only have one slider to deal with, which is specifically A, the value that we're looking for, right? So if I solve this thing for B, I need to divide both sides of this equation by A, which is a little bit weird because I have myself a fraction here. So it's going to look like this. I'm going to divide by A. On the left-hand side, this is going to go away. The A is going to go away because I divided it by A, and I have B is equal to whatever 65 over 7 divided by A is. So I'm taking a fraction, and I'm dividing fractions. Don't I do the whole keep, change, flip thing? So dividing by A is the same thing as multiplying by the reciprocal, which is 1 over A. So that looks like a 6, I can see, but I'll make that a B. Okay. So this is the same thing as 65 over 7 times 1 over A, multiplying by the reciprocal. Top times top and bottom times bottom is 65 over 7A. So what I'm going to do is I'm going to set up an expression that forces B to be equal to 65 over 7A. And now I won't have to worry about my B slider. We have a set value for it. So let's go back to Desmos. And I could probably get rid of some of this stuff here. And actually, let me doctor this thing up. I think I can use this one as my B value. So B, throw in an equal sign, and then go down here where this 7 is, and then put an A. So right now it is highlighting with a little error message, both box 1 and box 4. The reason why is because there's two different B values, and I want to keep the one that's in box 6, but I don't want the slider. So if I just delete the slider here, everything will work out perfectly. And now you can see that I just have one slider to move to try to get it to this point of intersection, the one that they gave us, which is the 0, negative 99 over 7. So let's just slide this thing, make this thing happen, and you can see, oh, we're super, super close. It looks like it's at 5, and I can zoom in, zoom in, zoom in, zoom in, and it's like right there on the money, and I can see here that I've got an A value of 5, which is exactly the solution that we got by solving the thing algebraically.